the radians. Okay, still going to work with the radians. I got an angle of 2 radians. What quadrant does it fall in? I'm not trying to trick you. We don't do quadrants in radians, do we? We do it in what?
Degrees.
We do it in degrees, though, right? So what can I do with 2 radians?
Plug it in.
Convert it to
Degrees.
degrees, yes. Now, hey, notice, do I have a pi with it? No. So you shouldn't either when you type it in your calculator. So go ahead, convert it for me. I'll ask somebody here in a second what it's going to be converted. Oh, and whoa, not yet. I'm going to call on somebody. Or do you have a question?
I'm just like answering.
Okay.
It's 2 radians.
All right, we all set. So when I have 2 radians, what's it going to convert into? About how many? Just give me about how many, Will?
140 degrees.
Yeah.
114 degrees.
About 114 degrees. Everyone has that, about 114. All right, now what quadrant am I in, Will?
2.
Quadrant 2. There you go. No big deal. All right, what about an angle of 7 radians now? 7 radians. What quadrant am I in? 7 radians. About how many? Just round it a little bit. About how many? So if I'm at 7 radians, that's about how many degrees there? Leah? About 401. Oh, not one of my strong suits, is it? You know what I've been preaching here. I'm not a big fan of anything over 360. So what do you suggest they do? Maybe some of you could do that. That's fine. Figure out what quadrant 401's in, but I'm not a big fan. I like to see it smaller. Subtract what from it? 360. That's a nicer number, huh? That's going to give me what? About 41? 40? No, that's not 41. Is it? Yeah, it's 41 degrees. All right, so if I'm at 41 degrees, what quadrant am I in, which is the same as 401? 41 degrees. Going back to you, Will. First quadrant, yep. Hey, leave the calculator down, please, for this next one. I'm trying to get you guys in the habit just to have it up here, these quick ones. 180 from yesterday. 180. Anybody remember how many radians are in 180 degrees? Pi radians. Yep, pi. All right, these are ones I want you to try. I'm not. You can always use your calculator. All right, I'm not going to slap your hand away if you use your calculator to do it. But just things we're going to use over and over again to make it go quicker. And then here we go. Radians and the quadrantal angles. This is the second time we're going to write this down, so hopefully it becomes familiar. One quadrantal angle. Where do we start? 90. 90 is pi over 2. We just went over 180, right? That is pi. Anybody remember 270? 3 pi over 2. And this is probably the biggest one I need you to remember. 360. 2 pi. Yep. There's going to be 3 others we do on Monday, but those are the big 4 right there. All good. All right, so that was just a little review. Make sure we can convert on the calculator. Here's the big part of today. I'm going to give you a formula, not on the formula sheet that we need. Okay, so sorry, you do have to memorize something in this class. Here's the deal with it. You're going to start in a circle. You're going to do go back to your geometry days here. Not too much, so don't start complaining. I'm going to have the center, and I'm going to draw this in. Anybody remember what that's called in the circle?
Half circle.
Radius.
Radius, yeah, radius. Yep, I'm going to draw in a radius, and I'm going to draw in another one, which is the same length, and everyone see that angle I formed right there.
It's 90
Okay.
degrees. I can tell.
You flip it up and it's 90.
Can we just stop wasting the oxygen in this room now? Please. Killing me right now. So I draw in both the radii, and everyone see this angle that I formed. Okay, I know you don't remember it from your geometry days, but that's called a central angle right there. All right, that's called the central angle. The angle formed by 2 radii when you draw it in. So again, this is your radius, right? And then the third piece I'm going to introduce today is, do you see the arc on the circle that it makes? I'll highlight it for you. See this part right here?
Yeah.
There you go. That's the arc that it makes. And there's a relationship between all three of them. Okay, there's a relationship between all three of them. Ready for the formula that you're going to put in the box here? It's SOAR.
What?
It's SOAR. Ready? S, and that's awful. All right, relax. S, that's my cursive lowercase s. You guys know we don't do cursive anymore, so.
Why is that S not?
Do what you want, Max. I don't care.
Why is that one special?
So we're good to write just S?
Yeah, just write an S. And then I'd be like, oh, your S looks like a 5, and then I'm still done. You know, I'm still toast. S equals, ready? Greek symbol coming up, new Greek symbol.
Oh, degrees.
Mega.
Anybody know that one? Theta. That's theta. That's theta. The Greek symbol theta times R. Everyone see the SOAR now?
Where's the
Maybe
E?
not. Okay, sorry, I can't do that. I'm done. All right. S equals theta R. Here's what each piece means. S, and it's already up here. S is the arc length. Okay, that's what S stands for, the arc length. Wild guess what the R stands for. Radius, yeah. And then I have one more value, don't I? What haven't I talked about yet?
Central
angle.
Theta.
The theta, right?
Theta.
Yeah. And theta is your central angle, but here's where I'm going to start getting fired up. If you want to use that formula, ready? This angle has to be in radians. Okay? You cannot listen to the words that are coming out of my mouth. You cannot use degrees in this formula. Well, what if I'm given degrees? Convert it. Thank you. That's what we've been spending the last day on. So this has to be, make a note, your central angle has to be in radians to use this formula. If it's not, you got to convert it before you plug it in. It's got to be in radians before you plug it in. And you know I'm going to give you degrees. All right, let's see how we do on these. I got a radius of 4, arc length of 8. How many radians would it be? How many radians? All right, let's take our time because we're all new to this. Anytime you see the word radius, this is the only time this year I'm bringing up that word radius, so you know it's got to be associated with the SOAR formula. It's the only time I'm using it. All right, let's take a breath. S is my arc length. S is my arc length. What did I tell you was the arc length up here? Because it was given to you. Marat, here you go. What's the arc length?
8.
8. Everyone ready? 8 equals, I'm looking for how many radians. So we're going to keep theta as theta. And then what's my radius length up here now? Radius length from the problem. Joe? What's the radius length of number 5? 4. So times 4. How do you get rid of the 4? Make it easy on you. Divide both sides by 4. So how many radians are in that angle? 2 radians. There you go. 2 radians. It's just, I will most likely give you 2 out of the 3 values, and you'll find the third for me. 1 does not make you great. Let's go to 6. Maybe not even 2. Radius of 1.7. Ooh, find the length of an arc with an angle of 2 radians now. All right, let me go through each part of the problem and you tell me where everything goes. Marat, back to you here. Where's the 1.7 get plugged in for? Radius, good. So I'm going to plug in 1.5 for that. All right, let's keep reading together here, Marat. Fine, yep. Measures 2 radians. Where's the 2 going?
The radius.
Radius is 1.7. The central angle measures 2 radians. So where's the central angle go? Where's that 2 going to go in for?
Why did you put a length on
Is it 1.7?
Oh, all right, relax. Everyone's got a comment. 1.7. All right, where's the 2 going? Central angle, whose measures 2? Which one up here represents the central angle?
That little circle.
The theta. Theta, use your big words. Theta is 2. What's S mean again, Marat?
The arc length.
And that's what, find the arc length, right? So that's what we're solving for. You good over there, Nick?
Certainly.
Yeah, I'm sure. Oh, and you good?
I'm good.
3.4. We can move on. Arc length's 3.4 inches. Oh boy, now it gets nuts.
It's getting nuts now.
Pendulum?
Oh, that's the swinging thing.
Do I need to Google search this or are we good?
That's the swing.
Pendulum on a clock?
Tyler's got it.
It's like just like that, right? Yeah. It's got the little like oval, the little
Oh, it's
circle
like
on the bottom,
grandfather
right?
clock.
Yeah, yeah.
Yeah.
Back and forth,
12
yeah.
o'clock rooster crows.
Yeah.
Nick loved that one. That's a good one.
We still got a long year to go too. Long way to go.
Only like 14 more weeks.
For the test, yeah.
Yeah.
Big
What are we
day,
doing
big
after?
day.
Just watching
Oh, we're having
movies?
some fun.
Oh, you're
Don't
watching
worry.
some movies?
Yeah, we're gonna be having some fun.
After we really get the stud points going.
Everyone's got to pass though. No movies if everyone doesn't pass. All right, here's the deal now.
They give us the
You got to, I'm going to give you a little word problem. Yeah, it's a pendulum, but now you got to read through and say, all right, what's the arc length? What's the central angle? And what's the radius here? So I got a pendulum swings through an angle of, let's start here, 0.55 radians. Automatically, where's that got to get plugged in for? An angle of 0.55 radians. Where's my only angle up here? At an S, theta, and R, which one's the angle?
S, R,
Theta.
Theta.
Let's go through this again. And this is my fault. S is the arc, the length of the arc. Theta is the angle that it makes, the angle. R is the radius length. So if this says it swings through an angle of 0.55 radians, where's the 0.55 going?
Theta.
In for theta, yes. 0.55. All right, now we got to make a little decision now. What is the distance does the tip travel if it has a length of 8 feet, the pendulum? The pendulum has a length of 8 feet.
It would be the radius.
So my pendulum here, the pendulum going back and forth, it's got a length of 8 feet. So what should the pendulum 8 go into? The R or the S here?
R.
What's S mean again?
Arc length.
Arc length. What distance does it travel?
Oh.
Right? What distance does it travel if the pendulum has a length of 8 feet? So where should the 8 go?
R.
In for R. That's the arc. That is the radius length. And we're looking for arc length here.
I'm ready for the test now.
Yeah. Right. Yep.
Some sass.
I'm not even too sure on this one. That can't be a human calculator. 4.4 feet. Yep.
Do you think we're all going to pass the regions?
Honest answer.
That's way too long to be a guess.
You want my honest
It's
answer?
too early to
Yeah.
tell.
With the, what have we been here, 7 weeks?
Yeah.
I think all 13 of you are going to easily pass it if that's a huge if, you put in the work.
Dude, we're still
You can't just roll in that day and be like, I'm passing. That's not happening. All right. And people do fail this. Last year, nobody failed. No pressure or anything. Last 2 years, nobody failed. No pressure.
We gotta keep that
Okay.
What happened 3 years ago?
I don't remember back that far, but kids have failed. And it's pretty easy. It's not because their math knowledge isn't there or I'm not good at math. It's just because they didn't put in the work.
Figure out what a
I had one kid go on vacation like 3 weeks before the test. Oh, no shock he didn't pass because you weren't here for the review. So,
Okay.
all right, here we go. I only got 2 more here. I don't want to get fired up about the regions yet. We still got time. Okay, back to the pendulum. Swings through an angle of 30 degrees. Where's that 30 degrees going? An angle of 30.
To the
No, it is not. It is not going in for theta.
Oh,
It
it's
is
the
not
S.
going in
It's
for
the
theta
S.
because theta has to be in what? Radians. So off to the side or in your calculators right now, I need to convert because 30 does not go in the formula. The radians version goes in the formula. That's where we got to be disciplined. 30 pi over 6. So I don't want 30 in there. I should see pi over 6 now plugged into there. All right, now, hey, we're not out of the woods yet. Is everybody good? You've got to convert before you plug in. I'll do that to you all the time to have you fall in that trap. The tip of the pendulum travels along an arc whose 4 pi inches long. Where should I put that 4 pi? Travels along the arc. That's 4 pi long. Where's that going to go? And then find the length of the pendulum if that helps you. Where's this 4 pi going? S. Yes, it travels along the arc. So 4 pi over here. And now we're solving for R. I know some of you might get nervous there. How do you get the pi over 6 out of there? Divide, yeah. And I don't have any sympathy for you. You guys know how to do the fraction templates on the calculator. So 4 pi divided by pi over 6. Let's see what you got. Thank God for these calculators because just doing it by hand just extends this.
No point in doing this. He already said what's happening.
Mr. Carlino said I pi.
Get the grade back. Well, he said it.
And what do we end up here? Radius length?
24.
24. What do we got? Inches here? Yep. All right. Good. Using theta equals S equals theta R. All right. This last question has nothing to do with theta R. Actually, some of you guys had this on your Delta Math yesterday and asked, so maybe you can teach me now.
Teach the teacher.
Smaller angle formed at 5 o'clock. So I got 12. I got 5. Well, I want to know what's that angle measure, the smaller one in radians. All right, well, what's our, I don't know how to do it in radians, but I can do it in degrees and then convert, right? So how do I find what this angle is in degrees right now?
360.
I take 360 because that's the degree measure if I went all the way around. And we said it's cut up into how many equal parts? 12 divide by 12. And we said that was what, 30? Yeah. So every time you go from 1 to 2, 2 to 3, et cetera, it's 30 degrees. So I'm going 12 to 5 though.
Times 5.
Should be times 5, yep. So that's an angle of what?
130.
Okay, but that's not my answer because we asked for it in what? Radians, yep. So you take 150 degrees, convert it.
It's going to be
5 pi over 6. 5 pi over 6. You know the deal. Here we go. You're going to have a lot of S equals theta R problems on Delta Math. Right up to the bell here. We got plenty of time. Right up to the bell.
I'm doing that stuff in my head.
No pop quiz on Monday. It's on Tuesday. Remember, do not plug degrees in, right? Do not plug degrees in. Change it into radians before. You guys got plenty of time here to get that few done, if not all.